This tool is called Andromeda, which helps you explore high-dimensional data, such as this dataset of cars. The original format of the data is tabular and looks like this. Note that every row is an individual car and every column is an attribute of those cars. The main component of Andromeda is a projection of the data such that the closer together that 2 points are, the more similar they are. Note that the x and y axes of this projection are meaningless. The information portrayed in this projection is strictly through the relative distances between the points. The attributes of the data are listed to the right of this projection, with each attribute represented as a slider. Hovering over a point will provide you with a tooltip for the name associated with the point, which may be useful if points are plotted along the edge of the panel or if multiple points are plotted close together. Additionally, the hovered point will turn yellow, and corresponding yellow points will appear along the attribute sliders. These points on the sliders represent the attribute values associated with the hovered point, where points towards the right of the slider indicate higher attribute values than points towards the left of the slider. Clicking on a point will turn the point orange permanently. Similarly, the points along the attribute sliders will turn orange and also become permanent. With the points along the attribute sliders permanent, you can hover over each individual point to see the exact values associated with the selected point. If you have more than one point selected, hovering over them reveals the individual attributes for every single point that is selected. The attribute sliders are interactive. Simply hovering over an attribute will show the attribute values associated with each car. These values are indicated by the width of the borders around each point. These sliders can also be dragged to allow you to explore different perspectives of the dataset. This can also be thought of as exploring different definitions of similarity. For example, dragging the city miles per gallon attribute up will increase the influence of this attribute. Dragging it all the way up means that this attribute alone almost exclusively influences the projection, resulting in a near-linear projection of the data based on each car's city gas mileage. The node sizes and opacities for each of the points for the cars will be adjusted based on which cars have high values for the most influential attributes. Additional sliders can also be dragged up if you desire multiple sliders to influence the projection. However, note that sliders adjust themselves relative to each other. This means that sliders can be thought of as representing a percentage of the whole. Therefore, if you want 2 sliders to be considered equally, you should pull the second one only halfway up. Similarly, for a 3rd slider to be considered equally, you should pull the slider a 1/3 of the way up. If you were to pull it up less than a 1/3 of the way, then it would have less influence. Of course, you can drag sliders down as well. If you do not know which sliders you should drag to express a certain similarity or dissimilarity between points, you can instead drag points together and apart to represent their desired similarities and dissimilarities. Note that as you drag these points, they will turn orange. By clicking Update Layout, the points and their relative similarities and dissimilarities will be used to automatically determine which sliders should be manipulated and how they should be manipulated to represent the similarities and dissimilarities between the points. Only the orange points will be considered in this calculation. No other points, regardless of where they are located in relation to the orange points, will influence the calculation in any way. This means that creating a large equilateral triangle of 3 points is effectively the same as creating a small triangle. In other words, what matters is the ratios of the distances between the different pairs of points. Because of this reliance on the ratios, at least 3 points must be orange in order to create enough distances or ratios for this calculation to be effective. Once the calculation is complete, the slider manipulations will be applied to the entire projection so that you can see the similarities and dissimilarities between the other points as well. For example, in this case, the attributes normalized losses, city miles per gallon, and height were the three attributes that had the most influence between the expressed similarities and dissimilarities between the orange points. These sliders were then automatically manipulated to influence the entire projection. If at any point you wish to return to the initial projection of the data, you can click the Reset button. This returns all points in sliders to their original positions.